Okay, I'm going to talk for a moment about compression, particularly in application to mathematical operations. So we're going to start with exponentiation, move on to multiplication, and then addition. Um, there's a reason for this order. I want you to think about order of operations and why this idea of compressed notations might actually play into that the order of operations is not arbitrary, but there's a reason for it. So exponentiation, anything to the 0 power is 1. We're going to start with this basic fact. And then, basically, all that exponentiation is repeated multiplication. So we're going to pick a base of, let's say, 7. Okay, we've got a 7 in here. 7 times 1 equals 7 to the first power, which of course is 7. As we add these on, notice that this chain of multiplication gets much, much longer. However, the exponentiation notation is a compressed form of this. These mean the same thing. This means take 7 and multiply it by 1 7 times. And so does this, only this is a more compact form. Okay, let's look at multiplication. So multiplication is also sort of a compressed notation, this time of addition. So we have our multiplication table here of single-digit numbers. And let's say we want to multiply, 3 times 6. So what does this mean? Well, it means we're taking the number 6 and adding it up 3 times. So I could take a different one and like this, a square number. Notice it's a square, hence it's a square number. 6 times 6, so it's basically adding 1, 2, 3, 4, 5, 6, and then another 1, 2, 3, 4, 5, 6, and so on until we've done that 6 times. So this is essentially the same thing as saying 6 plus 6 plus 6 plus 6 plus 6 plus 6. Well, that's a lengthy chain like it was for multiplication on the exponentiation page. This is a much more compact form, especially as you get larger and larger numbers. Well, how about addition? Surely it's not also a compressed notation. Actually, it is, and I want to take this very simple example of adding apples and oranges. So we've got 6 apples and 4 oranges. How much total fruit do we have? Well, in order to do that, what you really do is count. So addition is sort of a compressed notation for counting. For counting, we're going to apply what's called a successor operation. In other words, we're going to say, okay, add one more on. What comes next? So in order to count, and you may remember doing this as a child when you had to add, or maybe some of you do it now. When you add, you have to use your fingers to count. Essentially, that's what we're doing here. So what I'm going to do is add 6 apples and 4 oranges by simply counting them. And I'm going to use like a little tick mark, check mark to show which ones I've counted here. And you'll see the updating total right here. It starts at 0, of course. So we have 1 apple, 2, 3, 4 apples, 5 apples, 6 apples, 7, 8, 9, 10. So essentially what we've done is, use our fingers or our tick marks to count up the combined total of 6 apples and 4 oranges. Of course, it's much, much more efficient to learn how to do addition. And you can express all of these tick marks using this notation, 6 plus 4. This is just another compressed notation. So anyway, think about order of operations and why this sort of idea of these compressed notations might play into why exponents come before multiplication and why multiplication comes before addition.